Welcome. When most of us look up, we see clouds as just, well, pretty shapes, or maybe a sign that rain is on the way. But if you're a pilot, they're a living, breathing map of the sky, and they're packed with absolutely crucial information. So today, we're going to learn how to read that map.
So let's start with the official by-the-book definition from the flight training manual. It's very scientific, right? A cloud is just a bunch of water or ice floating in the air, and we can see it because it reflects light. Simple enough.
But that definition, it doesn't really tell you the whole story, does it? It doesn't tell you about turbulence or about the air's stability or what the atmosphere is actually doing up there. So, for someone whose life literally depends on understanding the sky, what is a cloud really? That's the question we're going to dig into.
Okay, let's get into it. Here's our flight plan for today. First, we'll look at the sky from a pilot's perspective. Then, we'll get into the three main cloud families. After that, we'll uncover the surprisingly simple recipe for how all clouds form, and finally, the most important part, we'll learn how to read the signs.
You see, for a pilot, the sky isn't just a pretty canvas. It's more like a dashboard, and it's full of live data. Every single cloud is a visual clue about what the air around you is doing. Is it rising, sinking? Is it stable, or is it turbulent? The clouds make the invisible visible. They turn all that abstract atmospheric data into something you can actually see and interpret. All right, so to even begin reading all this data, we've got to learn the language first. And just like a biologist classifies different species, pilots classify clouds. And the whole system is super logical. It's based on just two simple things: how high the cloud is and what it looks like.
And you'll be happy to know the naming system is actually pretty straightforward. It all comes down to altitude. If you see the prefix Cirro, you're talking about a high-level cloud, way up there above 16,500 feet. Alto means it's a mid-level cloud, and if there's no prefix at all, well, that's a low-level cloud, hanging out below 6,500 feet. That little prefix is an instant giveaway for its altitude.
Okay, so that's altitude. Now let's talk about what they look like. First up, we have cirrus. These are those really thin, wispy, feathery-looking clouds. Because they're so high up, they're made entirely of ice crystals, which is what gives them that delicate, almost painted-on appearance.
The second type is stratus, and the name says it all. It literally means layer. These are those flat, sheet-like clouds that can cover the entire sky like a big gray blanket. They basically look like fog that decided not to sit on the ground. And a sky full of stratus clouds, that's a huge sign of very stable air.
And our third main type is cumulus. This one means heap or pile. And these ones, they're the classic puffy cotton ball clouds with the flat bottoms and the bubbly tops that look kind of like cauliflower. Now, unlike those stable stratus clouds, these puffy cumulus clouds are a direct signal of rising air currents. They mean the air is unstable, and these are the ones you've really got to watch.
So we've sorted clouds by what they look like and where they hang out. But how do they even get there in the first place? Well, it turns out that everything from a tiny wisp of cirrus to a massive, towering thunderhead, they all share the exact same basic recipe.
And here it is, the whole process in a nutshell. You take some air that has moisture in it, you force it to go up, and as it rises, it gets colder. Once it cools down to a very specific temperature, we call that the dew point, that invisible moisture suddenly condenses into the visible water droplets that we see as a cloud.
Let's break that down into three dead simple steps. First, you need lift. Something has to give that moist air a push upwards. Then, as it rises, it cools. It's a process called adiabatic cooling. It's the same reason a can of compressed air gets cold when you use it. And finally, once it's cool enough, the water vapor will condense, turning from an invisible gas into tiny liquid droplets or ice crystals. Lift, cool, condense. That's the whole magic trick.
Now, that first step, lift, that's the real trigger for the whole shebang. So what in the world is powerful enough to lift these massive parcels of air miles up into the sky? Well, there are a few main ways this happens that every pilot needs to know.
The most common one is convection. The sun heats up the ground, but it doesn't do it evenly, right? A dark runway gets way hotter than a green forest next to it. So the air above those hot spots warms up, gets less dense, and starts rising in these invisible columns called thermals. And if that rising air has enough moisture, you guessed it, those puffy cumulus clouds. Next up is something called orographic lift. This is just a fancy way of saying the wind ran into a big physical barrier, like a mountain range, and had nowhere else to go but up.
If the air is stable, you'll probably get those layered stratus clouds just draping over the mountainside. But if the air is unstable, you could see cumulus clouds bubbling up right over the peaks.
And finally, there's turbulence. When you get strong winds blowing over rough ground, it creates this kind of mechanical mixing. All that churning can actually be enough to lift a whole layer of air a few thousand feet up. And when that happens with moist air, you often get a solid deck of low-level stratus or stratocumulus clouds.
So, here's where it all comes together. This is the crucial part. We have all the pieces of the puzzle, we know how to identify clouds, and we know the processes that create them. So now we can put it all together to actually read the sky and understand what it means for flying.
And this comparison just lays it all out perfectly. Look at the difference here. When you see those layered stratus clouds, you can bet the air is pretty stable, and it's going to be a smooth ride. But if you fly into that layer, your visibility will be terrible. On the other hand, when you see those puffy cumulus clouds, you know there's rising air, which could mean a bumpy ride from those thermals, but you'll have great visibility in between the clouds. See? The shape tells the story.
So what's the big takeaway from all this? It's simple, really. Clouds aren't just random decorations. They are the visible evidence of what the air is doing all around you. Every single cloud is telling a story about lift, about stability, and about moisture. And for a pilot, learning to read that story isn't just a cool skill, it's absolutely essential.
So the next time you look up, I want you to try to see more than just shapes. See the processes. See the stable layers of stratus. See the rising columns of air creating cumulus. The sky is talking to you all the time. The real question is, can you understand what it's saying? After today, you're a whole lot closer.